Welcome back. We now have the ability to move our mouse, and our spring arm is able to follow along with the rotation of our controller, which is what we're actually rotating with our input. Now, I'd like the mesh to rotate along with the spring arm. In other words, I'd like it to follow that control rotation. Now, there isn't a built-in way to do so for a static mesh component. The spring arm has the ability to follow the control rotation, but our mesh does not. But we know how to rotate our mesh, don't we? We can use event tick, and we can take our bot mesh, and we can simply set world rotation on the mesh. And all we need to do is use the rotation of our controller. Now, there's a handy way to get the controller rotation. It's with a function called getControlRotation. The control rotation is the rotation of our controller. If we pass that in, then every frame we're setting the world rotation of our bot mesh to the control rotation. And if we press play and engage, now we see that our drone's mesh is following the rotation of our controller. Now we can fire our blaster beams wherever we like. Pretty nice. And we now have the opportunity to see what happens if we look up and our camera collides with the floor. Take a look at that. This is thanks to our spring arm. It's shrinking in as our camera collides with the floor. And that is a very nice feature. So now we're rotating our mesh around along with the controller. The only thing left is to be able to move forward, backward, left, and right. So we need another input action for movement. So I'm going to go back to my input actions folder, and right next to my other two, I'm going to make a new input action called IA_move. I'm going to open that up and change its value type to axis 2D, just like IA look. Only this time our axes are going to be left and right movement and forward and backward movement using the WASD keys. So I'm going to go to IMC bot and add a new mapping and choose IA move. And for IA move, I want to add 4 keys, W, A, S, and D. So I can click on the keyboard icon and hit W, and I have W assigned. But I also need to click plus and get another one. I'm going to click on that and press A. I'm going to add yet another one, assign the value S, and yet one more, and assign the value D. Now, each of these is going to result in triggering IA move, but we need to know the difference between each of these 4 keys to know whether we should move left, right, back, or forward. Now, IA move is 2-dimensional, much like IA look. It has an X and a Y value. If we go into BP bot pawn, we can move event tick down just a bit, and just under IA look, I'm going to get the event IA move. And just like IA look, it has an action value. We can break it and access the X and Y values. Whenever our input action is triggered, in other words, while we're holding WASD down, X and Y are going to have values, right? Well, by default, a single keyboard key press goes straight into X. It's going to be a value of 1 while the key is pressed. But I only want that for A and D. I want to assign A and D left and right movement to my X axis for this input action. But by default, they all just go to X. We can see what we mean by printing a string and passing in the value X to that string on triggered. And if we go back and press play, and we press W and hold it down, we get a value of 1 spammed to the screen. If I press S, same thing, a value of 1 spammed to the screen. If I press A, same thing. And if I press D, same thing. So we need a way to distinguish between these 4 keys because they all simply result in the same thing, and that's the x-axis of this vector receiving the value 1 when triggered. Well, that's fine for the D key. I want to move right when we press D, but I want to move left when we press A. So it'd be great if this value is negated when I press the A key. So in IMC bot, I can go to A, and we know about modifiers. I can click plus to add a modifier to the A key and choose negate as the modifier, expand it, and choose to negate the value of X and leave Y and Z alone. And now if we still print the value of X when we trigger IA move, we can see what happens when we press the A key. We get a -1. So D gives us 1, A gives us -1, and that allows us to distinguish between pressing those 2 keys. Now that's all fine and great, but how do we actually move the pawn? Well, rather than calling functions to move the pawn like add world offset and such, it's better to make use of some of the built-in movement components Unreal has. We've seen that projectiles can fly through the air using projectile movement components. But our pawn is not a projectile. It's actually controlled by user input. And there's a perfect movement component for that. It's called floating pawn movement. So let's add a new component and search for floating pawn movement. Let's get a floating pawn movement component. And now that we have that, we can use this component to move our pawn. For instance, I'd like to move the pawn to the right when we're pressing the D key. So here's how we can do it. We can get our floating pawn movement component and call add input vector. Add input vector requires a world vector, that's a world direction, and it's going to move our pawn in that direction. Now, what direction do we want to move? Well, I'd like to get my control rotation with get control rotation, and I'd like to get a vector from this rotation, not the forward direction of this rotation, but the right direction. In other words, I can call get right vector. The right vector of this rotation is exactly what we expect. If our controller is oriented in a certain direction, the right vector is pointing to the right of that. So if I hook that in and hook up add input vector to triggered, and I press play and hold the D key down, I'm going to move to the right. But if I press the A key, I'm still moving to the right. That's because we need to use this X value, which is 1 when we're pressing D, but -1 when we're pressing A, and we can scale this vector by it. I can drag off, get a multiply node, convert that second pin to float, and hook X into it, like so, and hook that into the world vector input for add input vector. And now if I go back, I can press D, and I move right, and I can press A, and I move left. How about that? Now we just need to do the same thing for moving forward and backward. Let's do that. Now, if we press W and S, we're still just going to get values in the x-axis. We need a way to tell this input mapping context that the values W and S are not supposed to go to the x-axis, they're supposed to go to the y-axis. We can do that with another type of modifier. Let's start with W. Let's add a modifier. And the modifier we're interested in is called Swizzle Input Axis Values. If we choose that and expand the index, we'll see that the order in which the values are populated in this input action, they're swizzled, they're switched. Y takes precedence. It says YXZ, which means that when we press W, we'll get a value of 1 straight into the Y-axis instead of the X. We can do that for W, and we can do that for S, because S is supposed to be moving backward, right? So I'm going to add a modifier, choose Swizzle Input Axis Values, And we can see that it goes straight to the y for s. But in the case of s, we also want a negation modifier because we want to move backwards, right? So let's add an additional modifier. And for this one, we'll choose negate, and we'll expand that and choose to negate only the y-axis. So now w goes straight to the y-axis, s goes straight to the y-axis, but it's also negated. So we can go back to our botpon, and we can call add input vector yet again, passing in our floating pawn movement. This is a function on that class, except we don't want to get the right vector, we want to get the forward vector this time. So I'm going to get control rotation and call get forward vector, and this should be multiplied by our action value's y value. So I'm going to multiply and convert the second pin to float and drag that y value straight over and hook it into the world vector. And we can go ahead and test this out by pressing W and S, and now we can move around. Isn't that nice? So now we have floating movement. We can move forward, backward, left, and right. Perfect. Now, I know a question that's on your mind. It's bothering you the same as it bothered me and other people who learn this for the first time. Why is X left and right and Y forward and backward when we all know that forward is the X-axis in Unreal Engine? Forward and backward is always the X-axis. Left and right is always the Y-axis. So why is this reversed? Well, the answer is because IA move is two-dimensional. It's an axis 2D. It's a 2D vector, only X and Y. And in a two-dimensional axis coordinate system, left and right is typically X, and up and down is the Y-axis. So in 2 dimensions, left and right is the X-axis. But in 3 dimensions, we, at least in Unreal Engine, we consider X to be forward. So this is the way that it should be. But if you disagree and you feel like your W and S should be the X-axis, you can make that happen. It's up to you. You can swizzle input axis values on A and D if you want instead of W and S. But in mathematics, in 2 dimensions, X is left and right, Y is up and down. It's only in 3 dimensions in Unreal Engine that X is forward and backward and Y is left and right. So I leave that up to you. Now, one more thing before we wrap this up is we need to clean up these nodes because this is looking messy, right? It's convenient that we can take our action value and break it, but we don't like our wires reaching across if we can help it. Now, remember, when we right-clicked and searched for the input action, there were 2 options. One was the event, and the other was simply enhanced action values. So if I select IA move down here, we get that pure function, right? This is allowing us to access the input action value. This allows us to avoid having to break that output pin from IA move. We can simply get it from this node. Let me show you. I'm going to take break vector 2D and delete it and get IA move and break this. We'll use break vector 2D and look at this. We have it here. So I can use this instead. We're multiplying by the X-axis here. And I can copy these nodes and come over here. And we're multiplying by the Y-axis here. Very nice. And if we wanted to, these could become handy little pure functions as well. This one is for handling left and right input. So I'm going to right-click and collapse it to a function and call it get right input vector. And I'm going to check pure in its details panel. And it says right, but it's left and right. And for these nodes, I'm going to collapse them to a function and call this get forward input vector. And I'll make this a pure function as well. And that's collapsing those nodes down a bit. And then we can also take all of these nodes and collapse them to a function. I'm going to do that, collapse to function, and I'll call this handle floating pawn movement. And this one can't be pure. We have to hook it up to the triggered execution pin. So we're just going to leave it like that. And there we go. And if we want to, IA look can have its nodes collapsed as well. We can collapse this to a function called handle look input. And we can rename the input vector to action value. And now this is nice and neat as well. And finally, our tick function down here can have its nodes collapsed if we want. We're setting the world rotation. So let's collapse this to a function called rotate mesh to controller or something similar. And now our nodes all look nice and neat. This is always a good idea. We want to keep our nodes as neat as possible because otherwise they will very quickly get out of hand. And I've seen Blueprint event graphs that are such a mess, they're extremely difficult to work with. You don't want to get to that point. And in fact, if you like, as I mentioned before, you can collapse these nodes to a function as well. I'll just go ahead and do that. And this can be called add input mapping context. We can keep the comment though. I'll go ahead and keep that there. And I'll check on the comment show bubble when zoomed, like so. And now our blueprint graph looks very neat, very nice. And after making changes like this, it's always a good idea to go back and play test and make sure things work as they should. Excellent. So we now have floating pawn movement. Things are looking great. Excellent job. And I'll see you in the next video.